lesson 6.2, writing and solving proportions. Now we're going to define proportion here in just a second, but let's kind of lead up to it. We're going to look at equivalent ratios and equivalent rates. Now one of the pair of equivalent ratios we know are indeed equal in value, are 1/2 and 2/4, 1 to 2 or 2 to 4. And so because they're equivalent, it says we can equate them. That means we can set them equal to one another. Those two ratios are equal in value. We can set them equal. This, when you set two ratios equal to one another, you get what we call a proportion. A proportion is an equation that states that two ratios are equal. And so this is the generic one. A over B, or A to B, is equal to C to D, where B can't be 0 and D can't be 0. The denominators can never be 0. These guys, the numerators and the denominators, the A, B, C, and D, they're called the terms of the proportion. This is the first term, the second term, the third term, the fourth term. The A and the D, that's on this diagonal, they're called the extremes. The B and the C, that's on this diagonal, they're called the means. Now what we're going to do is we're going to consider proportions in which one of the terms is a variable. Like in the example I have down here. You can see that the third term is the variable x. And we can look at this and we can say, what would x have to represent for these two ratios to be equal to one another, for this to be a true statement, a true proportion? And that's what we're going to go about to solve. Now we can kind of look at this one and we say, well, if we multiply this by 5, by 4, we'll get a 20. So if I multiply the bottom by 4, I'll multiply the top by 4, and that better be a 12. X better be 12. Well, there's a little bit more efficient way to determine that, rather than just kind of sitting back and looking to see what we have to multiply times 1 to get to the other, because sometimes it's a fraction. And that's what we're going to look at next. We will use what we call the cross product property of proportions to help us when one of the terms is an unknown, when one of the terms of a proportion is a variable. Now you'll notice here that it says the cross products of a proportion are equal. That means if you multiply on the diagonal, if you multiply the extremes together and multiply the means together, that's these two terms and these two terms, that they should be equal. A times D, B times C. Those are sometimes just called the cross products. And of course, B and D cannot be equal to 0 because you can't have 0 in the denominator. So this is the proportion that I just looked at. I already know what the answer is. The answer is 12. But now I'm going to show you how you can use this property to find it. I'm going to multiply by the way, the cross product property is sometimes called the product of the means equals the product of the extremes. I'm going to multiply the extremes together. That's these two guys here. And I'll bring it over here. That's 60. 3 times 20. I'm going to multiply these two together. And I'm going to bring it over here. That's 5x. And I'm going to set them equal because it says that they're equal. Well, now I have a simple equation that I solved earlier. We've solved this type of one-step equation before. And you can see exactly 60 divided by 5 is indeed 12. X has to be 12. That's what we had already figured. Here's one with some slightly bigger numbers. I'm going to multiply these two together here. These are the extremes, and I get 54 times x, or 54x. Here I'm going to multiply these two together. Yikes. See, 117 times 6. Ooh, smokes. That looks like that would be 700. Oh, my goodness. 702. Let me see. I'm going to have to do this one out. 2, carry a 4, 0, carry a 1, 702. Now I'm going to solve for x. That's this product here, and that's this product here. I'm going to divide both sides by 54, and I get x is equal to, now 54, yikes, 54 into 702. We'll use these big numbers. 1 here, 54, subtract, that's a 6, that's a 1, that's a 2. Looks like it goes in 3 times on the nose. All right, so 13. And there's my answer right there. Now this one has a decimal on it, but don't get intimidated by that. I still do this cross product, that's 63. And I do this cross product here, that's going to be 1.5x, and I'm going to set them equal. Now I'm going to divide both sides in this problem by 1.5, whatever's times the variable, and I get x is equal to now 1.5 into 63. I'll have to slide it once, I'll add a 0, and I'll slide it once, and I'll bring it straight up. 15 doesn't divide into 6, but goes into 63 4 times. 4 times 15 is 60. 3, bring down the 0, goes in 2 times. on the nose, 42. Now they don't always come out to be integers, but these first three examples here all did. Sometimes you'll get fractions or decimals, and that's why the previous way I showed how to work this by looking to see what you would multiply top and bottom by doesn't always work conveniently. You should use your cross products. You should become very dependent on cross products. Proportions will help you in a lot of different kinds of problems, including many kinds of problems that you'll see in the next chapter when we get to percents. So now let's see. Tell whether the ratios form a proportion. Well, that means if I set them equal to one another, do I get a true statement? Okay, so that seems simple. If I set them equal to each other, will I get, that's supposed to be a question mark, not a very good one, will I get a true statement? Well, that's where I have to check the cross products, because if the cross products are equal, then they form a proportion. But I can tell you right now, I don't think that's going to happen here. If I do this cross product and bring it over here, 72 times 11, that's 72, that's 72, that's 792. And then I do this cross product and bring it over here, I don't think it's going to work because I think this one's going to end with a 4. 67 times 12, that's 4 carry 1, that's 13, that's 67, that's a 4, that's a 0 carry 1, that's 804. They're close, but they are not equal, so the answer here is no. They do not form a proportion. The cross products have to be the same. Now I'll check this one where the numbers are a little bit smaller. Are these indeed equal? Well, if I do the cross product here, 7, that's the extreme, 7 times 16 is 112. And if I do the cross product here, 28 times 4, and bring it over here, that's a 2 carry 3. Yep, I'm going to get the same thing. They are equal, so my answer to this problem would be yes. If the cross products are equal, then they form a proportion. Now I have a little story problem here. It says the worms in Janet's compost bin can break down about 0.25 pounds of food scraps per day. How long would it take the worms to break down 8 pounds of food scraps? So what I'm looking at is 0.25 in 1 day. That's the number of pounds of food scraps, and that's the time. This is a rate, right? And then over here, 8 pounds in how many days? So let's call it X. And I'm going to set these equal because it says that it would take them so much for the 1 day. We assume that the worms work at a nice steady rate. So I'm going to do cross products here. I have to be very careful. That would give me, here, I'll bring it over here because I'm running out of space, 0.25x, and this would give me 8. I'm going to divide both sides by 0.25, and I'm running out of space. You'll have to take my word for it, or you can check with a calculator. When you divide, you will get 32. So it will take 32 days for those worms to break down 8 pounds of food scraps. You can practice these a little bit later on in some of the other units that we'll be covering, but we want to make sure we're good at it now so that when we get to those other topics, we're ready. So remember, practice, practice, practice.